on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Till you are going to report me this, let me just brief you what is the ideal duration and what is the agenda for today's session. Friends, the ideal duration for today's session is going to be approximately 45 minutes. And the agenda for today's session is that today we are going to have the second part in the sequence of previous year questions from IIT Kanpur, because the next year GATE 2023, IIT Kanpur is going to be the organizing institute. In my first session also I told you before starting the session that the intention of this session and the series of session is not to tell you that similar questions or same type of areas can be again asked in 2023. We are here just to discuss the conceptual part of the questions and give you a morale boost up or give boost up to your confidence when you are going to appear in the GATE 2023 examination. So everybody who is joining me live, just quickly confirm your presence and tell me whether my audio, visual quality, everything is clear. And do not forget to like, share and subscribe the session. Everybody just hit the like button, share it with your friends and colleagues so that more and more people are going to be joining with us. And subscribe to BYJU'S Exam Prep if you have not subscribed, so that you do not miss any of your important session. So shall we start, everybody? Just tell me. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from IIT BHU in 2010, written a couple of books, and my areas of expertise are power system, electrical machines, electromagnetic field theory, material science, engineering ethics, and I'm also taking current affairs also. Before we proceed for the session, a very important information for all the serious aspirants for GATE 2023. BYJU'S Exam Prep is bringing a live GATE workbook exercise. You won't believe, but this is really going to be a live workbook exercise, because we are going to discuss 500 plus important questions for your GATE 2023 examination. We are going to cover all the major engineering branches: civil, mechanical, electrical, electronics, instrumentation and computer science. It is going to be started. The classes are going to be started from 25th of August. So set your alarm right and do not miss any of these sessions. And we are calling this series as GATE Champion Series. So all the champions, just tell me in the comment section, are you able to follow this? Let us discuss the first question. The question says, a 240 volt single phase source is connected to a load with an impedance of 10 ohm 60 degree. A capacitor is connected in parallel with the load. If the capacitor supplies 150 volt ampere reactive, then what is the real power supplied by the source? Actually, this question is quite easy, but I want to give you some understanding of the question. What the question is saying? Question is saying there is a single phase voltage source, and this voltage source is giving supply to a load, and this load is, what is the value given? It is 10 angle 60 degree. So this load is 10 angle 60 degree. Now he is saying a capacitor is also connected in parallel with the load. So capacitor is going to be connected something like this. Yes or no? And he is saying in the question that the voltage source is having the voltage as 240 volts. So this is 240 volt and single phase source. And for the capacitor, he is saying the capacitor is supplying 150 volt ampere reactive. That is the reactive power supplied by the capacitor. So capacitor is supplying in the system 150 kVAR. Sorry, it's not kV, it's VAR. Now please try to understand what is happening here in this system. If you talk about the load, suppose the load requirement is P load plus JQ load in terms of the real and reactive power requirement of the load. Yes or no? The load requires this much real and reactive power. Now, even though we know the value, still we are saying, suppose this is the reactive power supplied by this shunt capacitor. It is acting as a shunt capacitor for this system, yes or no? Suppose this is the reactive power supplied by the shunt capacitor to the load or the system. Now, the remaining requirement of the load reactive power has to be supplied from here. And you also see that there is no real power exchange when it comes to the shunt capacitor, because shunt capacitor is only delivering or supplying the reactive power. So, suppose the real and reactive power sent from the source end is, suppose it is PS plus J, and it should be Q load minus Q shunt capacitor. Yes or no? Whatever amount of reactive power for the load has been compensated by the shunt capacitor. After that what is remaining, that is being taken care by the source. But you see, capacitor is not having any exchange of real power. So, whatever is the real power requirement of the load, that has to be supplied by the source only. It means whether this capacitor is present in the circuit or not, there will be no difference in terms of the real power exchange. Are you getting this point? Tell me yes or no in the comment section. And he is asking the real power supplied by the source. It means whether this capacitor is present or not, we are not interested. So, can you tell me what is going to be the real power? Yes, the real power is going to be V square upon Z, and this is going to be cos theta or cos phi. What is V? V is going to be 240. What is the Z magnitude? The Z magnitude is going to be 10. And what is this cos phi? This is going to be cos of 60 degree. Just solve this. As per my reference, you must be getting 2880 watts. So, what is the correct answer? B is the correct answer. Is it clear, everybody? Just tell me in the comment section, are you able to follow this? Yes. See the next question. The conductors of a 10 kilometer long single phase 2 wire line, they are separated by a distance of 1.5 meters. So, the situation is something like this. This is suppose conductor A, and after some distance you have the another conductor, that is conductor B. In the question he is saying the length of the conductors is given as 10 kilometers, and it is a single phase 2 wire line separated by 1.5 meters. So, this distance is given as 1.5 meters. He is saying the diameter of each conductor is 1 centimeter. So, what is the radius? The radius of each conductor is going to be 0.5 centimeters. He is saying if the conductors are of copper. Now, this is something very, very important. This is where most of the people are going to do the mistake. I will tell you what is the concept here. He is asking the inductance of the circuit. First thing you understand, what is the meaning of single phase 2 wire line? Single phase 2 wire line is something like this. This is the load. This is a complete circuit. This is the forward circuit or forward path, and this is the return path. Suppose this is the A conductor and this is the B conductor. So, whenever he is asking the inductance of the circuit, that is also called as loop inductance. He is asking the inductance of the circuit. This is also called as loop inductance. Then what you have to do? It means you have to find the total inductance. This total inductance or loop inductance is going to be LA plus LB. Are you able to follow this? Are you able to follow this? And because of the symmetry, because if you see the radius for both the conductors is going to be same. So, you just find the inductance value for one conductor and just multiply it by 2, because it is going to be same for both the conductors, yes or no? Now let us see, what is the inductance formula you are having? Can you tell me? We are having the inductance formula mu naught mu r conductor divided by 8 pi. Mu naught mu r conductor upon 8 pi. Then we have plus mu naught mu r medium divided by 2 pi, and then we have ln d upon r. Is it clear for everybody or not? Just tell me yes or no. And this is Henry per meter. This is Henry per meter. What is this mu r value? Please try to understand. This represents the inductance due to the internal flux linkage. Internal flux linkage. And when you are inside the conductor, it gives you the relative permeability of the conductor material. Are you getting that? Now see, in most of the cases what is happening? This is the relative permeability of the medium, because right now you are talking about the external flux linkage. This is the external flux linkage. This is the inductance because of the external flux linkage. I hope you are getting this idea clear in your mind. Now in most of the cases what is happening, the conductor is made of aluminium material. Conductor is made of aluminium material. If conductor material is aluminium, it is aluminium, then what is happening? Sometimes some things happens for the sake of good in our life without any effort. It is just our destiny. So if you are having aluminium, this mu r for the conductor becomes approximately 1. And for the medium, if the medium is air, because if you are talking about the overhead transmission line, then this mu r medium also becomes what? 1, because this is the air. Yes or no? So this is something happening coincidentally, but it has a great advantage. Now if the conductor and material is aluminium, you can directly write mu naught upon 2 pi, you can take as common. So from here mu r conductor is gone as 1, so mu naught upon 2 pi if you take, it will be 1 by 4 plus. From the second term, mu naught upon 2 pi is taken as common and mu r medium is 1, then you will have ln d by r. How we can write this 1 by 4? We can write this as mu naught upon 2 pi ln. Wait, yes, this 1 by 4 we can write as ln e raised to the power 1 by 4. Same thing, yes or no? Just we want to have the standard relation. Now if you simplify this, you can write L as mu naught upon 2 pi, and this is ln d upon r e raised to the power minus 1 by 4. Now this e raised to the power minus 1 by 4 is nothing but the factor 0.7788, which you consider when you are doing the inductance calculation for our transmission line. I hope you are getting this. And this is because of what? This is because of internal flux linkage. This is because of internal flux linkage. And this is the reason when we calculate the capacitance, we are not including this factor 0.7788. What is the reason? The reason is, in capacitance calculation there is no internal flux, because we are dealing with electric flux, and electric flux cannot be present inside the conductor. Are you getting that? Anyways, but in this question what is happening, he is saying the conductor is made of copper, but the problem is, for copper they have not given the relative permeability. Are you getting that? So approximately, I am saying this once and again, approximately it should be given. For copper it should be given, but it is not given. So approximately, again we are taking mu r as 1, approximately. Otherwise actually we have to write the mu r value for the copper. I hope it is clear and you are able to follow this. Is it clear? Now, so let us try to put it in the expression and see what you are getting. So finally, if you write, you are writing this L as, what is mu naught upon 2 pi? Mu naught is 4 pi into 10 to the power minus 7. So it will become 2 into 10 to the power minus 7, and it becomes ln d by r, and this r is actually r dash, because you are using 0.7788 factor to write this as r dash, where r dash is 0.7788 r, and this is going to be Henry per meter. Now what I am doing, I am separating this 10 to the power minus 7 into 10 to the power minus 1 multiplied by 2, it will become 0.2, and 10 to the power minus 6 I am going to take here in the units, and I am going to write Henry as millihenry and meter as kilometer. I hope you are able to follow this. So we are writing the final expression 0.2 ln, this is d upon r dash millihenry per kilometer. But my friend, this is only for a conductor, and you know LA is equal to LB. So can I write L total as LA plus LB, or just multiplied by 2 because it is same. So it becomes 0.4 ln g upon r dash millihenry per kilometer. Just put the values and you will get your answer. Is it clear, everybody? Let me just put the values here. So this L total is going to be 0.4, and this is ln. What is D? D is, I think, 1.5 meters. D is 1.5 meters divided by r dash. So it is 0.7788, and it is 0.5 centimeters. So multiplied by 10 to the power minus 2, and this is millihenry per kilometer. Just calculate this. Okay. I think you must be getting this idea clear in your mind. Yes, everybody. Yes, can you just comment whether you are able to follow this or not, everybody? Are you able to follow this or not? Just tell me yes or no. Yes. Let us see the next question. The total reactance and total susceptance of a lossless overhead transmission line operating at 50 Hz, they are given as 0.045 per unit and 1.2 per unit respectively if the velocity of the wave propagation is 3 into 10 to the power 5 km per second. Then he is asking what is the approximate length of the line. Now let us first understand how you are relating the velocity of the voltage or current wave in the transmission line. So it is 1 upon under root LC. Is it clear, everybody? Are you able to follow this? What is this L and C? Can you tell me? What is this L and C? This L here is, it is Henry per kilometer. It means per unit distance. What is this C? This C is farad per kilometer. Kilometer or meter, whatever you want, because we are dealing with kilometers in transmission line. So we are writing like this. Now we have to change it to the total inductance and total capacitance. It means if this is the per kilometer value of L, then we have to multiply by L to get the total value of the inductance and capacitance. So what I am doing here, just see here, I am multiplying by L in the numerator and denominator. So inside the square root, it becomes L square. So I am writing L into L and C into L. Can I write like this? Yes or no? So inductance per unit length of the transmission line multiplied by the length of the transmission line will give you total inductance. So this is going to be L upon under root, this is L total multiplied by C total. Yes or no? But in the question he is not giving you L and C, he is giving you, my friend, reactance and susceptance. It means we have to transform this L and C into omega L and omega C. So again we have to multiply and divide by omega. So we are writing this as omega into L in the numerator, and in the denominator it will become omega L total and again this is omega C total. Now you can write it V as omega L upon under root. Now this omega L total will become what? It will become X total multiplied by this omega C total will become B total. What is B? B is the susceptance. X is the reactance and B is the susceptance. Are you able to follow this? But these are the total values, and in the question he has given you the per unit values. He has given you the per unit values of reactance and susceptance. It means another modification we have to do. Again we have to write it in terms of the per unit. Can you write it? Very easily. So what we are doing, omega L, suppose Z base is the base impedance. So we are writing X total divided by Z base. Then we have B total. Now in case of B total, we have to use the base admittance. So instead of writing base admittance B total upon base admittance, we can write base admittance as 1 upon impedance. So this base impedance will go upside. Let me tell you how you should be writing B total. Sorry, B in per unit, B total divided by Y base. Now this Y base I am writing as 1 upon Z base. So this Z base will become here. So that is what I am writing. It is B total into Z base. Are you able to follow this? Are you able to follow this? Tell me yes or no in the comment section. So you can write the velocity as omega L upon, this will become X total, but this is the per unit value, and B total, and again it is the per unit value. Now you just put the values and you will get the answer. What is the velocity given? What is the velocity given? 3 into 10 to the power 8 meter per second, because it is given as 10 to the power 5, but that is kilometer per second. So we have to write in terms of meter per second. Yes or no? Yes or no? Then we have omega L. What is omega? 2 pi and this is F. Okay. Then length you have to find divided by under root. What is the X and B value given? It is 0.045, 0.045 and 1.2. Just calculate what is the value of L. Or one thing more you can do, instead of writing 10 to the power 8, you can write simply 10 to the power 5 only, but you have to write it in terms of kilometer per second, so that now finally when you are getting the length, you are getting the length directly in the kilometer, no need to change it again. Is it clear everybody? Just tell me yes or no. So as per my reference, you must be getting 222 kilometers. Are you getting that? So what is the correct answer? C. Is it clear everybody? Just say yes or no. All the candidates who are joining me live, just quickly hit the like button, okay? And do not forget to share it with your friends and colleagues. Very, very important. Let us see the next question. He is saying a 50 Hz alternator is rated as 500 MVA 20 kV with a XD is given as 1 per unit and XD double dash, that is the subtransient direct axis reactance, is given as 0.2%. It supplies a purely resistive load of 400 megawatts at 20 kilovolts. He is saying the load is connected directly across the generator terminal when a symmetrical fault occurs at the load terminal. So this load is directly connected across the generator terminal and there is a symmetrical fault occurring at the load terminal. He is asking what is the initial RMS current in the generator per unit. First thing you have to understand, what happens when there is a symmetrical fault in the system. Yes? Is it clear, everybody? Let me just tell you. Suppose this is your generator. Okay. And suppose this is your load, maybe motor or something. And this is your generator. And suppose somewhere here the fault is going to happen. Now what will happen? If the fault is occurring at some point, what will happen? Just try to understand. Just before the fault has occurred, there must be some value of voltage. There must be some value of current here. Yes or no? I0. Yes or no? Just before the fault has occurred. Now the moment fault has occurred, what will happen? This generator is going to supply current to the fault, because this generator is thinking that something wrong has happened with the load. What is the nature of this generator? The nature of generator is whatever is the requirement of the load, if it is within the capacity of the generator must supply the power. Now generator is not aware whether there is a fault or something wrong has happened with the load, or there is more demand from the load. So generator will start sending more power and current to the fault. The same thing is happening to the motor. What the motor is doing? Before the fault has occurred, the normal power and current direction was like this. Now once there has been fault, now what will happen? The motor will decelerate. The motor will decelerate. For that purpose, less current is going to be there. Now the current in this direction becoming less is equivalent to that just before the fault current is in this direction, and just after the fault the motor also starts sending current in this direction. That is fault current contribution by the motor. Are you able to follow this? It means when there is a fault, both the generator and the motor, they are going to supply the fault current. But one thing I want to ask you. Just before the fault and after the fault, what is one thing that is not going to change for this generator or the motor? Can you tell me? Yes, that is EMF. EMF is something which is related to the mechanical phenomena. Mechanical phenomena means until and unless there is a change in the speed, that will not be reflected in the induced EMF. So just before the fault and after the fault, this EMF is going to remain as same, and this is what they are asking in the question. In the question they are asking the initial RMS current. For this initial RMS current, who is going to decide this initial RMS current? It is the sub-transient EMF induced in the generator that will decide the initial RMS current. Is it clear? And that EMF in the sub-transient period is going to be same as the EMF in the normal condition just before the fault. So what is the first thing we are going to do? We are going to find the pre-fault current and voltage. What is the pre-fault current? Because they are writing it in the per unit XD values, so we are also preferring to write it in the per unit. Is it clear? So we will be writing this as P divided by V cos phi. Okay, and this is also pre-fault. Now what is this P naught? What is this P naught? P naught is the power supplied to the load. The power supplied to the load, that is 400 megawatt. But this 400 megawatt we have to write in terms of per unit, and let us assume this is the base. This is the base MVA. This divided by 500, so it will become as 0.8. Is it clear? So it will become as 0.8. What is the per unit voltage? The per unit voltage, suppose you are assuming the voltage base to be 20 kilovolt. Voltage base to be 20 kilovolt. So it will become as 1. What is cos phi? What is cos phi? Cos phi is given or not? cos phi is given, okay, purely resistive load. If it is a purely resistive load, then it is going to be unity power factor. So this also becomes as 1. So can I write this I naught as 0.8 per unit? Is it clear, everybody? And it is going to be in the same phase as that of the voltage because it is purely resistive load. Is it clear? Now we are going to find the EMF just before the fault. So this is going to be generated EMF is equal to the pre-fault voltage plus current, and this is JXD because this is the normal condition, pre-fault condition. So we are using a steady state direct axis synchronous reactance. What is V naught? It is 1 angle 0 plus what is I naught? This is 0.8 angle 0, and this is JXD. What is the value of XD? XD is given as 1. So simply you are writing it as 1 plus J 0.8 per unit. But this is not changing just before the fault and just after the fault, and this is the EMF which will decide what is the initial RMS current in the circuit. So what is going to be initial RMS current in the circuit? That is, we are writing it as EF double dash. This is going to be EG, and that will only be decided by the subtransient reactance because there is a fault. So no load is there. So this is going to be JXD double dash. What is this EG? This is 1 plus J 0.8 divided by what is JXD? This is J. What is the value of XD double dash? That is subtransient reactance 0.2. If you solve this, you will be getting the per unit value of the fault current as 4 minus J5. Okay. If you want, you can calculate the magnitude also. Then magnitude of IF double dash you will be getting as per my reference as 6.4 per unit. 6.4 per unit. This is separate. Is it clear? What is the answer you are getting? 6.4. Is it clear, everybody? Are you able to follow this? Just tell me yes or no. No comments till now. If you are watching it, if you are understanding it, why not? Just tell me yes or no. See the next question fast, no problem. There is a bundle conductor, okay, and the bundle conductor is going to have some conductors, that is this, they belong to one conductor, that is the bundle conductor. In the other phase, they are assuming that there is no charge. He is saying if we neglect the charges on the other phase conductor, because he is representing only one phase conductor. Now some points they have mentioned X, Y, W, Z, and they are asking at which of the point the electric field intensity is going to be maximum. Now suppose these subconductors are having some charges. Okay, we are not interested in the actual magnitude of the charges. That is surface charge density, obviously. Q is here, surface charge density. Let us talk about point number Y. Because of this conductor, suppose this is A1, this is A2, and this is A3. So because of A1, at point Y, the electric field will be something like this, EA1. Because of A2, the electric field will be something like this, EA2. And because of this subconductor A3, the electric field will be something like this, EA3. This is the condition at point X, sorry, point Y. This is point Y. Now let us see at point W. At point W, because of A1, this will be EA1. Because of A2, it will be EA2. And because of A3, it will be EA3. At point Z, because of A1, it will be EA1, something like this. Because of A2, it will be EA2, something like this. And because of this A3, it will be something like this, EA3. If you talk in terms of point Q, for point Q, it will be EA1 radially outward. For A2, it will be EA2, and for A3 it will be EA3. So if you compare all the points, they are asking at which point you have the maximum electric field stress. So obviously at point Y, here you are getting the maximum electric field density because all these electric fields are going to be added together. They are approximately in the same direction. Otherwise, the phase angle displacement is too much, so the net electric field is going to be less. So point B is going to have the maximum electric field intensity. Let us see this question. A composite conductor consists of 3 conductors of radius r each. The conductors are arranged as shown below. The geometric mean radius of the composite conductor is kr. What is the value of k? Now please try to understand. Suppose this is A1, this is A2, and this is A3. So how you are writing the GMR? How you are writing the GMR? GMR of this conductor system is going to be GMR of A1, then we have GMR of A2, and then we have GMR of A3, and what is the power? 1 by 3, because you want only one GMR. And because of the nature of the symmetry, A1 is going to have A2 and A3 same as A2 is having A1 and A3, or A3 is having A1 and A2, because they are sitting on the equilateral triangle vertex. Yes or no? So can I say, because of the symmetry, GMR A1 is equal to GMR A2 is equal to GMR A3. If this is the case, then for the total system GMR is simply going to be, you can write it for any one of the subconductor. Suppose we are writing it for A1. How to write it? Just see here. Effective radius of A1. What is the effective radius of A1? 0.7788 r. Now, the distance between A1 and A2 and A1 and A3. This is also 3r, this is also 3r, and this is also 3r. Is it clear, everybody? So this is going to be 3r and this is going to be 3r. How many distances? 1, 2, 3. What is the power? 1 by 3. Now you have to do the calculation part. Just put the value of small r and capital R. Okay, small r and capital R. Okay, this no need of small r because radius itself is given as capital R. So this has to be capital R itself. Just put the values of r. R will come out, yes or no? R will come out because r cube, so r will come out. Now you have to do this calculation. 0.7788 into 3 3s are 9. So this is 1 by 3. And this is going to be your k value, yes or no? This is going to be your k value. Just calculate this. As for my reference, I think, I am not sure, you just calculate it. Yes, you must be getting it as 1.913. 1.913. Just confirm this value. Okay, just confirm this value, 1.913. So this is all from my side, friends, for today. Thank you so much for joining me live in the discussion. I hope you are going to enjoy these sessions. So do not forget to like, share and subscribe to BYJU'S Exam Prep. And I am giving you my personal Telegram channel on BYJU'S Exam Prep that you can follow, and you can ask me n number of questions, that is electrical by Ashutosh Saxena, which is my name. So thank you so much, friends. Stay connected. We are coming up with some more wonderful sessions for your upcoming GATE 2023 preparation. Thank you so much. Take care. Thank you. Thank you, everyone.